Hi, welcome to Nomis Academy. In this video, I will be teaching you joint variation. Joint variation. If you have not watched our previous videos, please go and watch so that you can understand the preceding one. So this is joint variation. Joint variation. So what is joint variation? If you have watched our direct variation and inversely variation, you will understand that joint variation is just the inclusion of the two or three parameters involving one of them or two of them at the same time. What am I saying? Joint variation is when a quantity varies with two or more other quantities. For example, the area of rectangle varies jointly with its length and breadth. Varies jointly. That is, as one and the other one increases or decreases, it affects the other one. What am I saying? Remember that area of rectangle is equal to length times breadth. So let's say the length of a rectangle is 3 and the breadth of a rectangle is 2. So that tells that the area of the rectangle will be what? 6. So what happens when the length changes to 4? And let's say the breadth still remain. Will it affect the area? Yes. The area becomes 8. So what happens if the length changes to 4 and the breadth changes to 3? It will still affect the area of rectangle. And what happens here now? Let us study the variation that happens. Now it is 12. Now you see that as the length increases, the area of the rectangle increases, even though that the breadth did not increase. As the breadth increases, the area of the rectangle increases, even though the length did not increase. When the 2 increases, what happens? The area of rectangle increases. So it means that in joint variation, we can have inverse variation and direct variation between two quantity or more. Do we get it now? So let's take some examples. Let's say y varies directly as x. We could also have it to vary directly as z. But what happens too in joint variation? We could also have y varies directly as x and varies inversely as z. So we could have this work together at the same time. So it can still be y varies inversely as z and varies directly as x. So what is important is how to interpret this variation properly. So y is dependent of whatever x and z will be. So if z increases, y increases. If any of this increases, y increases. If any of this decreases, y will decrease. If one increases and the other decrease, then there will be an alteration with y. It's either it increases or decreases depending on the constant that occur between them. So that in this case, it becomes y equals to k x z. In this case, we have y equals to k x all over z, because this is 1 all over. So in this case, it becomes y equal to k x all over c. So we should be able to convert the proportionality that you express mathematically into an equation like this that can help you to solve the questions. Let's take some examples on joint variations and let's see how we can get to solve them easily. Example number 1. X varies directly as y squared and inversely as z cubed when x is equal to 2, z is equal to 1 and y is equal to 3. So the question says, find x when y is equal to 2 and z is equal to 1. So let's get down to the solution. So we have been given the parameters x varies directly as y squared and varies inversely as x cubed, z cubed. So that means this becomes x equal to ky squared all over z cubed. So we need to find the constant. So how do we find the constant now? So this becomes z raised to the power of 3 multiplied by x equal to ky squared. So divide both sides by y squared. This cancels this, so our k constant is equals to z raised to the power of 3 multiplied by x all over y squared. So z raised to the power of 3, what's our z? 1 raised to the power of 3 multiplied by x, what's the value of x? 2 all over y. The value of y is 2 raised to the power of 2. So 1 raised to the power of 3 is 1 multiplied by 2 all over 2 raised to the power of 2 is 4. So 1 times 2 is 2 over 4, and that is 1 over 2. So our constant is 1 over 2. Now let's find the value of x when y becomes 2 and 0 is still 1. So you can see y becomes 2, y was 3, but when y becomes 2 and 0 still remain as 1, what happened to the value x? So we are going to take on when x is the subject of the formula. So when x is the subject of the formula, we had x equals to ky squared all over z cubed. So k is 1 over 2 multiplied by y squared. What is y now? Y is 2. 2 raised to the power of 2. Everything over z. Z is still 1 raised to the power of 3. So this is 1 over 2 multiplied by 4